Welcome to the DIY Honda Garage channel. The DTC P0172, which stands for Fuel System Too Rich, indicates that the engine control unit, ECU, has detected an excessively rich air-fuel mixture in the combustion chamber. This condition arises when the amount of fuel being injected exceeds the level that can be adequately combusted given the volume of air entering the engine. Fuel system components that may be affected include the fuel injectors, mass airflow MAF sensor, and the air-fuel AF sensor. The ECU continuously monitors the air-fuel ratio and will set this Diagnostic Trouble Code, DTC, when the data falls outside predetermined limits. By addressing this code promptly, one can potentially prevent more severe engine issues that stem from running rich, such as fouled spark plugs or damage to the catalytic converter. The components primarily involved in generating DTC P0172 include the fuel injectors, mass airflow MAF sensor, and air-fuel AF sensor. The fuel injectors are responsible for delivering precise amounts of fuel into the combustion chamber. The MAF sensor measures the volume and density of air entering the engine, which the ECU uses to adjust fuel delivery. The AF sensor helps ensure that the proper ratio of air to fuel is maintained, critical for efficient combustion and emissions control. Additionally, the fuel rail pressure sensor and VTC, variable timing control, components can also influence the engine's fuel management strategy. Locations for these components vary within the engine bay, typically around the intake manifold for the fuel injectors and MAF, while the AF sensor is connected in the exhaust stream. Several potential causes could lead to the setting of DTC P0172. Firstly, faulty fuel injectors may cause excessive fuel to be delivered, resulting in a rich condition. Incorrect fuel pressure, whether too high or too low, can also lead to improper fuel mixtures. A defective mass airflow, MAF, sensor could misread airflow, causing the ECU to adjust fuel injection incorrectly. Additionally, damaged exhaust sensors, such as the A-frame sensor or HO2S, heated oxygen sensor, might provide incorrect data regarding the exhaust composition. Lastly, contaminated engine oil may affect the function of the PCV, positive crankcase ventilation system, contributing further to engine performance issues. Drivers may experience various symptoms if their Honda CRV is exhibiting DTC P0172. Common issues include poor engine performance, where acceleration may feel sluggish due to the incorrect air-fuel mixture. Increased fuel consumption may also be noticeable, as a richer mixture leads to more fuel being burned without adequate combustion. Rough idling can occur when the engine struggles to maintain speed effectively, creating noticeable vibrations. Furthermore, stalling may be prevalent, especially when transitioning from idle to acceleration, as the engine struggles to adapt to changing conditions. Lastly, black smoke from the exhaust indicates excessive fuel not being combusted, serving as a physical and visual symptom of a rich condition. The first step in diagnosing DTC P0172 involves verifying the problem under idle conditions. Start by starting the engine and allowing it to idle without any additional load. This is typically performed in the park, P, or neutral, N position. Using the Honda Diagnostic System, HDS, check the short-term fuel trim, STFT value. The normal threshold for STFT at idle should be less than 0.79. If the observed values match, this indicates that the STFT is indeed too low, guiding the technician to Step 3 for further diagnostic procedures. Conversely, if the STFT value is above the threshold, technicians should proceed to Step 2 in order to review additional diagnostic snapshots. In Step 2, the focus turns to reviewing the onboard snapshot recorded during initial diagnostics. Technicians should examine the key parameters at the point where the short-term fuel trim was at its lowest value. It's vital to record values such as engine speed, vehicle speed, relative throttle position, TP, and accelerator pedal position, APP sensor readings at this time. Following this, the vehicle should be driven under conditions similar to those documented in the snapshot to see if the short-term fuel trim again falls below the threshold of 0.79. Successful confirmation of this condition will drive the technician towards Step 3 for further analysis. On the other hand, confirming that the trim is within acceptable limits may hint at normal system operation, requiring a more detailed examination of underlying issues rather than outright fault identification. During Step 3, the technician will assess the fuel pressure on the low side while the engine is idling. Start the engine and allow it to maintain idle while monitoring the fuel pressure when the short-term fuel trim reads 0.79 or lower. This fuel pressure check serves as a critical diagnostic step to evaluate whether the fuel system is pressurizing adequately. If the fuel pressure is within specification, it can be concluded that low fuel pressure on the low side is not the root cause of the low STFT. If, however, the fuel pressure does not meet the necessary parameters, the technician will need to proceed with replacing the fuel tank unit as per the diagnostics. Step 4 involves checking the fuel pressure on the high side of the system. First, ensure the vehicle is turned to the off/lock mode, and then turn it back to the on mode. Clear any existing codes with the HDS diagnostic tool before starting the engine. Once the engine is running, the technician should hold the engine at approximately 3,000 RPM without load until the radiator fan engages, and then revert to idle. This will allow the pressure test to reflect accurate conditions. Within the HDS, select the DI fuel pressure test and verify whether the readings return normal. Failure to meet the required specifications will prompt further troubleshooting directed towards DTC P0087 or DTC P0088. In Step 5, if the earlier diagnostic steps have not identified the issue, it becomes necessary to assess the quality of the fuel in the tank. Start by turning the vehicle off and draining the fuel from the tank completely, followed by refilling with known good fuel from a reliable source. After refueling, the engine should be started and allowed to idle. The vehicle should then operate under the same conditions as identified during earlier diagnostics to see if the short-term fuel trim again indicates below 0.79. If it does, it suggests fuel quality has played a role. Otherwise, the technician will move on to Step 6. Step 6 focuses on testing the mass airflow MAF sensor value during engine operation. The technician will continue to let the engine idle, ensuring that the engine coolant temperature sensor, ECT sensor 1, is above 158 degrees Fahrenheit, 70 degrees Celsius. The transmission is in P or N, and all additional electrical loads are turned off. With these conditions confirmed, the technician holds the engine speed steady at approximately 2,500 RPM for 30 seconds. Monitoring the MAF sensor readings using the HDS. Ideally, the MAF sensor should display values ranging between 6.5 to 9.1 grams per second. If the current conditions align with this threshold, the MAF sensor is operating correctly, and further diagnostic steps can be taken. Should readings diverge from this range, inspection of the air cleaner assembly for damage or incorrect installation is warranted, and potential replacement of the MAF/IAT intake air temperature sensor may follow. In Step 7, the technician assesses the condition of the engine oil while the engine continues to idle. By gently pinching the PCV vacuum hose, the technician can evaluate changes in the fuel trim readings. This action temporarily alters engine pressure dynamics and can indicate whether oil contamination is contributing to the rich fuel condition. If the values remain less than 0.79, even when pinched, the engine oil is confirmed to be in good condition. However, if the trim value exceeds this threshold, it could indicate contamination, prompting a closer examination of potential causes, such as failing fuel injectors or other associated issues. And subsequently, replacement of the engine oil and filter may be necessary based on the findings. Step 8 covers the inspection of the evap canister purge valve, which can also impact fuel mixture richness. Begin by turning the vehicle to the off lock position and removing the high-pressure fuel pump cover along with the fuel bracket. Disconnect the evap canister purge valve 2P connector and its purge line from the valve. The technician will then connect a vacuum pump gauge to the purge valve. Upon starting the engine, the technician should check if the vacuum pump indicates vacuum. If a vacuum is indeed observed, this condition suggests that fuel vapors from the canister might be entering the intake manifold due to a failure in the valve. Replacement may be necessary to prevent excess fueling and resolve engine stall issues during operation. In Step 9, the focus is on the air-fuel AF sensor, Sensor 1. Begin by ensuring the vehicle is turned off. The technician should replace the existing AF sensor with a verified good unit to assess its impact on the short-term fuel trim at idle conditions. After installation, the engine should be started and left to idle. Under the same operational parameters, where the short-term fuel trim recorded below 0.79 previously, the vehicle must be tested to monitor the current AF sensor's influence on the fuel mixture. If fuel trim readings remain excessive, the original sensor suggests it was faulty, warranting replacement. Otherwise, revert the original sensor and move on to troubleshooting the injectors. The final troubleshooting step focuses on the fuel injectors themselves. The technician begins by ensuring the vehicle is turned to off lock before replacing the existing injectors with a known good set. After installation, the engine must be started and idled to allow observation of parameters related to the short-term fuel trim. The technician will again operate the vehicle under previously noted conditions associated with low STFT readings. The goal here is to confirm whether the injectors are now performing as expected or if the same issues persist. If the fuel trim values remain skewed negatively, it confirms that the injectors contributed to the rich condition. Should the readings stabilize and show acceptable levels, consideration of a PCM, powertrain control module, substitution may be needed to further investigate the remaining issues. Final repair verification is critical to ensure that all diagnostic trouble codes have been addressed effectively, particularly DTC P0172. After completing the repairs, technicians should conduct a thorough check of the relevant parameters to confirm normal operation. It is essential to ensure that the short-term fuel trim and other associated values have stabilized within their respective thresholds. Following underhood checks, a test drive of the vehicle is necessary to verify that the issue has been resolved under normal driving conditions. This step not only guarantees the performance of the vehicle, but serves as a preventative measure against recurring problems that could lead to further diagnostics in the future. Preventive maintenance plays a vital role in avoiding issues related to DTC P0172 in the future. Firstly, utilizing quality fuel from reputable vendors reduces the chances of fuel contamination affecting engine performance. Regular checks of the sensors, especially the MAF and AF sensors, can prevent them from becoming dirty or malfunctioning, which could lead to incorrect fuel mixture readings. Additionally, Maintaining proper engine oil levels is essential, as contaminated oil can affect overall engine performance and component function, leading to conditions that may trigger DTC readings again. Ensuring that all vehicle maintenance practices are up to standard will help extend the life of the engine while enhancing fuel efficiency and performance. In conclusion, DTC P0172 highlights the significant issue of rich fuel conditions within the Honda CRV's engine management system. The troubleshooting steps outlined provide a systematic approach to diagnose and rectify the root causes, ranging from fuel pressure assessments to evaluating sensor functionality and ultimately addressing injectors. Each stage requires careful monitoring of engine data, ensuring that technicians can reproduce and verify faults accurately. To prevent reoccurrence, proactive maintenance measures, such as using quality fuel and regularly checking key engine components, are essential. Keeping these aspects in mind will enhance vehicle reliability and prevent further complications from developing in the future. Please like and subscribe to the channel. See you next time.